Friends, thank you for being here today. What if I told you that a single Canadian materials engineer sitting in a Montreal certification facility possesses more power over American military supremacy than the Secretary of Defense? And what if I told you that this individual, whose signature appears on technical documents that most Pentagon officials have never seen, can ground the entire F-35 Lightning II fighter program and cripple American air power with the stroke of a pen? Most people believe that American military aircraft are built with American materials under American oversight, by American defense contractors operating according to American military specifications. They assume that the world's most advanced fighter jet depends on American industrial capacity and American technological superiority for its production and operational capability. They do not recognize what I recognize: the complete subordination of American military aviation to Canadian materials control, executed through certification systems so specialized that Canadian decisions about aluminum quality can determine whether American pilots have aircraft to fly. This is not supply chain management. This is the weaponization of materials science, placing American military readiness at the mercy of foreign technicians who control the certificates that determine whether American defense contractors can build the weapon systems that American national security depends upon. The F-35 Lightning II represents the most expensive and technologically sophisticated military aircraft program in history, with total development and production costs exceeding $1.7 trillion and operational plans that make this fighter jet the backbone of American air power for the next 50 years. The F-35 program involves over 1,800 suppliers across multiple countries. But the critical materials that determine whether these aircraft can be manufactured at all come from a remarkably small number of Canadian facilities that control the production and certification of military-grade aluminum alloys. 78% of the aluminum used in F-35 airframe construction comes from Canadian sources, specifically from facilities operated by Alcoa Canada, Rio Tinto Aluminum, and Norsk Hydro Canada, that produce the ultra-high-strength 7075 T6 aluminum alloy required for military aviation applications. This is not ordinary commercial aluminum that can be sourced from multiple international suppliers. This is aerospace-grade material manufactured to specifications so precise that deviations of hundredths of a percent in chemical composition can render the material unsuitable for military applications. The 7075 T6 aluminum alloy used in F-35 construction must meet stringent requirements for tensile strength, corrosion resistance, fatigue tolerance, and structural integrity that are essential for aircraft operating under the extreme stress conditions of military flight operations. These requirements are so demanding that only a handful of facilities worldwide possess the technological capability and quality control systems necessary to produce materials that meet military aviation standards. Canadian aluminum producers have invested billions of dollars over decades to develop the specialized smelting, refining, and quality control capabilities necessary to produce military-grade aluminum alloys. These facilities operate using proprietary processes and quality management systems that cannot be quickly replicated by alternative suppliers, creating dependencies that place American military aircraft production at the mercy of Canadian industrial capacity and Canadian policy decisions. But the production of military-grade aluminum represents only the first level of Canadian control over American military aviation. The critical choke point that gives Canadian officials the power to ground American military aircraft lies in the certification and quality assurance processes that determine whether Canadian aluminum can be used in American military applications. Every batch of aluminum delivered to F-35 production facilities must be accompanied by detailed certificates of compliance that document the material's chemical composition, mechanical properties, production methods, and quality control testing results. These certificates are issued by Canadian materials engineers working for Canadian companies according to Canadian quality standards and Canadian regulatory procedures that operate independently of American oversight or American approval processes. The individual Canadian materials engineer who signs these certificates possesses the technical authority to determine whether specific aluminum shipments meet the stringent requirements for military aviation applications. If this engineer identifies any deviation from specification requirements, any concern about production processes, or any quality control irregularity, the affected aluminum batch cannot be used in F-35 production until issues are resolved through additional testing, reprocessing, or complete replacement. The certification process for military-grade aluminum is extraordinarily complex and time-consuming, typically requiring 30 or 45 days for routine approvals, and potentially extending to 90 or 180 days when additional testing or documentation is required. During the certification period, affected aluminum cannot be used in aircraft production, creating immediate bottlenecks in manufacturing schedules that can delay aircraft delivery dates and disrupt military readiness planning. The mathematical reality of F-35 production dependency on Canadian aluminum certification becomes apparent when examining the scale of materials requirements and the precision of manufacturing schedules that modern military aircraft production depends upon. Each F-35 aircraft requires approximately 2,200 pounds of aluminum components, representing dozens of separate material deliveries that must each receive individual certification approval before they can be incorporated into aircraft assembly processes. F-35 production operates on just-in-time manufacturing principles that minimize inventory costs and storage requirements by scheduling material deliveries to coincide precisely with assembly line needs. This approach makes the entire production system vulnerable to delays in Canadian certification processes, as delayed approvals for even a single aluminum shipment can halt aircraft production until alternative materials can be sourced and certified. Lockheed Martin, the prime contractor for F-35 production, maintains only limited aluminum inventory at its Fort Worth facility specifically. Because military-grade aluminum is expensive to store and requires specialized handling procedures to prevent contamination or degradation, the company depends on predictable Canadian certification schedules to maintain production continuity and meet delivery commitments to the United States military and international customers. The vulnerability of American military aircraft production to Canadian certification decisions became apparent during the 2018 trade disputes when Canadian aluminum producers experienced what they described as quality control delays that extended certification times for military-grade aluminum shipments to American defense contractors. These delays occurred during periods of heightened trade tensions between the United States and Canada over NAFTA renegotiation, steel and aluminum tariffs, and other trade policy disputes that created incentives for Canadian companies to demonstrate their leverage over American military production. The timing of these certification delays was not coincidental. Canadian aluminum producers implemented enhanced quality control procedures and additional testing requirements during the same period when American trade negotiators were demanding concessions from Canadian negotiators on issues affecting Canadian aluminum exports and Canadian manufacturing interests. The correlation between trade negotiations and certification delays was obvious to American defense contractors, even though Canadian companies maintained that quality control procedures were implemented for legitimate technical reasons. The impact on F-35 production was immediate and severe, demonstrating how completely American military aircraft manufacturing had become dependent on Canadian administrative processes and Canadian policy decisions. Lockheed Martin was forced to slow aircraft assembly rates from 12 aircraft per month to 8 aircraft per month, and postponed delivery schedules for multiple international customers as Canadian aluminum certification delays created materials shortages that could not be quickly resolved through alternative suppliers or emergency procurement procedures. The company estimated that certification delays, lasting just 60 days, cost the F-35 program over $400 million in production inefficiencies, contractual penalties, overtime labor costs, and facility utilization losses. More importantly, the delays affected aircraft delivery schedules for the United States, Air Force, Navy, and Marine Corps, as well as international customers, including the United Kingdom, Italy, Netherlands, and other allied nations that depended on predictable F-35 delivery timelines for their military modernization programs. The cascading effects of Canadian certification delays extended throughout the F-35 supply chain, affecting hundreds of subcontractors and suppliers that depended on predictable aluminum deliveries to maintain their own production schedules and contractual commitments. Engine manufacturers, avionics suppliers, weapon systems integrators, and dozens of other companies found their operations disrupted by Canadian decisions about aluminum quality standards that they had no ability to influence or circumvent. The broader implications of the 2018 certification delays revealed how completely American military aircraft production had become dependent on Canadian administrative processes and Canadian policy priorities. American defense contractors found themselves unable to meet production schedules and contractual commitments because of decisions made in Canadian certification facilities by Canadian engineers operating according to Canadian quality standards and Canadian regulatory procedures. The psychological impact on American defense industry leadership was profound and revealed how completely American assumptions about military-industrial independence had become obsolete in an era of globalized supply chains and specialized materials requirements. Executives who had built careers around assumptions of American technological superiority and industrial self-sufficiency found themselves managing production systems that could be disrupted by foreign administrative decisions beyond American control, influence, or prediction. Board meetings at major defense contractors began including agenda items that would have been unthinkable just a decade earlier. Detailed discussions of Canadian regulatory policies, Canadian quality standards, Canadian political developments, and Canadian trade priorities that could affect American military production schedules and American defense readiness. Senior executives found themselves monitoring Canadian election results, Canadian parliamentary debates, and Canadian trade policy announcements as closely as they monitored Pentagon procurement decisions and military requirements. The transformation was most visible in risk assessment and procurement planning procedures adopted by major American defense contractors who recognized that their ability to fulfill military contracts and maintain production schedules now depended as much on Canadian administrative efficiency as on American engineering capabilities or American manufacturing capacity. Boeing, Raytheon, General Dynamics, Northrop Grumman, and other companies that produce military aircraft and weapon systems began incorporating Canadian certification risk into their project planning, cost estimation, and schedule development processes. These companies established dedicated liaison offices in Montreal, Toronto, and other Canadian cities, specifically to maintain relationships with Canadian materials, certification authorities, and monitor Canadian regulatory developments that could affect American military production. American defense contractors found themselves operating essentially as supplicants to Canadian regulatory authorities, seeking to maintain favorable relationships and preferential treatment in certification processes that determined whether American military programs could meet their operational requirements and delivery commitments. The strategic implications of American dependence on Canadian materials certification extend far beyond individual weapons programs to encompass fundamental questions about American military independence and American ability to maintain defense production capabilities during international crises or conflicts. Military aircraft production that depends on foreign certification processes creates vulnerabilities that could be exploited by potential adversaries or could compromise American military readiness during periods when international cooperation cannot be assumed. The Department of Defense has conducted classified assessments of American vulnerability to Canadian materials certification disruptions, recognizing that Canadian decisions about aluminum quality standards could affect American military aircraft availability more directly than enemy actions or equipment failures. These assessments reportedly conclude that prolonged certification delays could force reductions in American military aircraft production that would affect pilot training, mission readiness, and strategic deployment capabilities. American military planners have discovered that their aircraft availability and mission planning must incorporate Canadian certification schedules and Canadian regulatory procedures as critical factors affecting operational readiness. Traditional American approaches to military planning that assumed independent control over weapon systems production have been complicated by dependencies on foreign certification processes that operate according to foreign priorities and foreign timelines. The technological sophistication of modern military aircraft creates additional vulnerabilities because the materials requirements for advanced aviation systems are so precise that alternative suppliers cannot quickly replace Canadian aluminum sources without extensive testing, validation, and recertification processes that could take years to complete and cost billions of dollars to implement. The 775 T6 aluminum alloy used in F-35 construction must meet specifications so demanding that developing alternative suppliers would require massive investments in specialized facilities, proprietary manufacturing processes, and quality assurance capabilities that Canadian companies have developed over decades of research and production experience. The metallurgical properties required for military aviation applications are determined by extraordinarily complex manufacturing processes involving precise temperature control during smelting operations, exact chemical composition management during alloy production, specific cooling, and heat treatment procedures during processing, and mechanical treatment processes including rolling, forging, and machining that must be executed according to specifications that allow virtually no variation from established parameters. Canadian facilities have optimized these manufacturing processes over decades of production experience, developing proprietary techniques and quality control procedures that enable them to consistently produce aluminum alloys that meet the stringent requirements for military aerospace applications. These processes cannot be quickly replicated by alternative suppliers because they involve not only specialized equipment and facilities, but also accumulated expertise and institutional knowledge that Canadian companies have developed through years of experience producing materials for military applications. The certification procedures that validate aluminum quality for military applications are equally complex and specialized, requiring sophisticated testing equipment, advanced analytical capabilities, metallurgical expertise, and quality assurance systems that are concentrated in Canadian facilities that have invested heavily in military aerospace certification capabilities over many years. American defense contractors cannot simply switch to alternative aluminum suppliers without rebuilding entire certification infrastructures that would require years to develop, validate, and optimize for military applications. The development of alternative aluminum suppliers would require not only massive capital investments in production facilities and certification capabilities, but also extensive cooperation from the Department of Defense, American Military Services, and aerospace engineering organizations to modify military specifications, adjust aircraft designs, and recertify production processes to accommodate materials from new suppliers. These changes would affect not only current F-35 production, but also maintenance, repair, and upgrade procedures for thousands of aircraft that have already been manufactured using Canadian aluminum. The legal and regulatory framework governing materials certification for military applications provides Canadian facilities with substantial discretion to interpret quality standards, implement testing procedures, and establish certification timelines according to Canadian regulatory requirements and Canadian policy priorities. Canadian materials engineers are not required to prioritize American military production schedules or accommodate American operational requirements when making certification decisions that affect American defense contractors. Canadian certification procedures operate according to Canadian quality standards that may differ from American military specifications in ways that create opportunities for disputes, delays, or rejections that could affect American military aircraft production. Canadian engineers who identify discrepancies between Canadian quality standards and American military requirements must resolve these differences through additional testing or documentation procedures that can extend certification timelines indefinitely. The contractual relationships between Canadian aluminum producers and American defense contractors are governed by Canadian commercial law and Canadian regulatory procedures that give Canadian companies substantial flexibility to modify certification processes, adjust quality standards, or implement new testing requirements that could affect American military production schedules. American defense contractors have limited recourse when Canadian certification decisions create production delays or cost increases. The strategic effectiveness of Canadian materials certification leverage was demonstrated during recent trade negotiations, when Canadian officials suggested that American policies affecting Canadian industrial interests could influence Canadian companies' ability to maintain efficient certification processes for American military applications. American negotiators found themselves considering the military implications of Canadian certification delays when evaluating trade policies that might conflict with Canadian economic interests. The message was clear but diplomatically subtle. Canadian control over American military materials certification provided leverage that could affect American military readiness without creating grounds for formal diplomatic protests or trade dispute procedures. American officials recognized that Canadian certification decisions could impose costs on American military programs that traditional economic pressure or diplomatic sanctions could never achieve. The integration of Canadian materials certification into American military aircraft production has created a form of technological dependency that operates continuously rather than only during specific crisis periods. Every F-35 aircraft that rolls off American production lines contains Canadian aluminum that was certified by Canadian engineers according to Canadian quality standards, making American military aviation dependent on Canadian cooperation and Canadian policy decisions. The mathematical precision of this dependency cannot be disputed through policy rhetoric or alternative procurement strategies. American military aircraft production requires Canadian aluminum. Canadian aluminum requires Canadian certification. Canadian certification operates according to Canadian priorities and Canadian timelines. The numbers are clear, and they reveal the complete subordination of American military aviation to Canadian materials control. The transformation of materials certification from technical procedure into instrument of international leverage represents one of the most sophisticated but least recognized shifts in modern strategic relationships. The Canadian materials engineer who signs aluminum certificates for American military applications possesses more immediate power over American military readiness than most American defense officials. Canadian officials have demonstrated that modern military production is so dependent on specialized materials and precise quality standards that controlling certification processes provides more effective leverage over military capabilities than traditional forms of economic or diplomatic pressure. The certificate that validates aluminum quality has become more powerful than the aircraft it enables, because without Canadian approval, American military aircraft simply cannot be built. The age of American military independence is constrained by Canadian administrative procedures and Canadian policy decisions that operate through technical systems most Americans never see or understand. American fighter jets may bear American markings and serve American strategic objectives, but they depend entirely on Canadian permission to exist. The F-35, Lightning II. America's most advanced fighter aircraft and the foundation of future American air power can be grounded not by enemy action or technical failure, but by a Canadian materials engineer who decides that aluminum quality standards require additional review. This is how modern military power operates, through dependencies that previous generations of military planners never anticipated and current policymakers struggle to address. Most Americans believe their military is invincible, but American military aircraft production depends on signatures from Canadian engineers sitting in Montreal certification facilities. The F-35 kill switch is not located in the cockpit or the Pentagon. It is located in Canadian offices, where materials engineers decide whether American aluminum meets Canadian quality standards. The Canadian certification engineer may never choose to exercise this power, but the mere fact that it exists fundamentally alters American military planning and American strategic independence. America builds its most advanced fighter aircraft only with Canadian permission, using Canadian materials certified by Canadian engineers according to Canadian standards. This is how technological dependencies create strategic vulnerabilities. The materials that make American aircraft possible are controlled by foreign officials who answer to foreign governments with foreign priorities. The signature that validates aluminum quality has become the signature that determines American military capability. One Canadian engineer with one certification stamp controls the future of American air power. If this analysis opened your eyes to the hidden power structures reshaping our world, there's so much more you need to see. Hit that subscribe button and ring the notification bell, because the next video will expose something even more shocking that most people will never discover until it's too late. The world is changing faster than anyone realizes, and those who understand these patterns first will be the only ones prepared for what's coming next.